Hello guys and welcome. In this lecture we'll talk about the contours and how we can detect them using OpenCV. The contour detection is an important and useful tool for detecting objects and recognizing objects also. So first I will create a Python file. I will call it contour detection.py. I will start by importing CV2 and numpy, and then I will create an image. So if I create, for example, a white image, I'll call it image numpy dot. You can use once and give it the shape of the desired image, or just using full and giving it, for example, the shape as 512, 512 and 3, and giving it 255. It will be filled with white color, and then giving it data type as np.uint8, like that. You can show this image here in show image, call the image here and saying cv2.weight 0. If I run the code here, Python contour detection .py, and as you can see, this is this white image. I will create some shapes on this image to detect them using the OpenCV findContours methods. So I will create some rectangles and lines on this image. For example, cv2.rectangle on that image, and this function will take the top left corner and the bottom right corner. So if I give it here, for example, 10 and 50, for example, and also the bottom right, or the bottom right corner, if I give it, for example, as 100 and 400, for example, and if I give it a color of for example, blue color, 0 and 0, and if I give it thickness as 2, for example, I can copy this one many times, and I can change this. For example, if I use here 150 and 150 from here, and you can give it, for example, here 300 and 300 also, and you can use the same color, and you can put this rectangle inside this one. For example, if I use here 200 and here 200 also, and this to be 250, and here I can use 200 also, or 250. So let me show this image. As you can see, these rectangles here, if I make this, for example, filled, and I can draw also circle, for example, cv2.circle on that image, should use take the center. For example, if I give it center as for example 400 and 300, and the radius as 50, for example, with a color of 0, 0 and 255, red color, and also I can fill it with that color, and I can also draw a line here. So a line, and this will take the image, and the first point, if I, for example, give it like 450 and, or for example 480 with, for example, 50, and the other point as For example, the same, if I make like vertical line, it will be the same x, and I can give it, for example, 400 as the second point, and the color I can make, for example, green color, for example, 0, 255 and 0, with a thickness of 2 also. So let's show this image. So now we have created this image, and we can use the findCV2.findContours on this image. This function works better with binary images. So if I convert this image to a grayscale image and then using a thresholding method or canny edge detection method to get the binary image, and then use the findContours to find the contours on this image. So let me do that and create gray image using cv2.cvt color of that image, using cv2.color from RGB to gray, and also let me use, for example, canny edge detection. So canny, and that gray image with 127 and 255, and we can use these findContours on these edges. So this function takes the edges or the image, and the mode and the method, we will talk about this later. So if I use the mode as cv2 dot let's say, for example, tree, so return tree, there are many methods, for example, return tree or list or external, and these two ones also. So this tree here, it will detect all the contours, and each contour will be, it detects the contour, and for example, if this contour contains a contour inside it or an object inside it, it will also relay this object to the parent object or the object that contains it. So it will make some hierarchy like that, and this can be this will be defined in the output here. So this output will be contours. This will be the coordinates of each contour detected, and also the hierarchy of this contours, which will define if the contour is inside another contour or the object is inside another object or not. And this also is relies on this method or the mode we used here, which will define if the, for example, if we use a tree, it will make them as tree, and object or a contour is inside another contour or something like that. Or if we make a list of them, so all of them will have the same hierarchy. It will be all of these objects have the same level or are parents and there is no children's. And if we use just the external if we want just the external objects, we can use this external here. We will see all of them later. So now let me use this tree, for example. And the method here is will define if, for example, we want to get the methods, for example, chain, we have simple and none. So if we use simple, it will these contours here, it will contain just coordinates of a point or 2 points, for example, the extreme of each line, for example. But if we use none here, this method none, it will detect all, or it will return all points in each line. So for simplicity, it's better to use this approach simple. Now let's print these contours and hierarchies. So if I print these contours, let's print them first. So now, as you can see, for each contour, it's return 2 points of each line of this contour, for example. And if I print the hierarchy here, so if I if I, for example, run this code, and you can see here the hierarchy. So this hierarchy defines here the for example, this is the next, define the next contour. This is the previous contour in the same hierarchy, and this defines the child, and this defines the parents. For example, for this contour, the next contour in the same hierarchy is its index is 2. This contour, for example, doesn't have any previous contour in the same hierarchy, and its child is the contour with index 1, and it doesn't have any parents. For example, this contour is has a child, but it doesn't have a parents. This contour, however, so here -1 will indicate that this contour doesn't have a next or a previous, and also it doesn't have a child, but it has a parent, which is the 0, which is this contour here. So if I use the method cv2.drawContours on this image, and we can give it the contours. We can specify here, for example, the index of a contour, or if we want it to draw all contours, we can give it -1, and then we can give it the color of these contours. So if I give, for example, the yellow color, so it will be 0 to 155 and 255, and the thickness, I can give it, for example, here 4, and as you can see here, so if I come here and say, so now it draws the contours on these objects, on these detected objects. If we, for example, try we want just the external contours, that means this contour, for example, won't be detected because it is inside this contour, and it will just detect the external objects. So if I, for example, give it here list, in that case, if I print here hierarchy, so all these contours will have -1s here for the child and for the parents, and all of them will have the same hierarchy. So for example, this one, the next of this one is 1, and the previous is -1 because this is the 0, the first one, and this is the next of this one. This, for example, is the with index 1, its next is 2, and its previous is 0, and all of them don't have child or parents, and it is like that. So for the last one, it doesn't have a next, but its previous is 12. This is the 13th contour. So now let's try it with another image, like for example real image. So if I comment this out, and if I come here and saying image is equals to cv2.imread, if I read an image from the data folder, for example the Sudoku image, and if I want just the external here, and if I comment this, if I print also here the edges, cv2.imshow edges, and here saying edges, so this is the edges, and these are the contours detected. You can also use another method like thresholding, for example, in this method. So if I comment this and saying here, for example, edges as cv2.threshold of this gray, leaving it 127 and 265, and cv2.binary or threshold binary, and if I print it here, so now it detects just this part. So if I, for example, comment this and uncomment these parts to show it in the last image we have created, if I run the code here, so this is the edges detected and these are the contours. And if you look at this, so it detects here this as a contour, which is the borders of this image, and of course that's we don't want this to happen. So if I come back here and saying tree, for example, tree, and show it here, so this is the tree, and as you can see we have drawn here the contours on these objects, but it gets rid of this line here, for example, on these edges, and therefore there is no contours drawn here. We can work on these parameters here. We can, for example, use another type of thresholding to get better image. So this depends on the application and on the image that we are working on. This is just an example, and we'll see more methods related to the contour detection in the next lectures.